Okay, hello everyone. I will present firstly myself. I'm Xudong. I come from China, but now I'm a PhD student here, and I'm in the last year, the third year. This is my my tutor, Mr. Lawahi Benabu. And today I would like to introduce a little about my thesis. The title of my thesis is the multi-scale simulation of the low temperature sintering bonding for optic using silver particles. The silver particles here, we would like to simulate this process in multi-scales. Multi-scales, it means that in nanoscale and macro scales. So why I talked about the multi-scales? Because the method of the simulation have to be based on the scales. First of all, the nanoscale. Nanoscale simulation, we use molecular dynamics simulations. This process make us to enter the nano world of the silver particles. Under some constraints, the physical constraints or the temperatures or some other physical quantities, we can make sure the sintering process can be simulated well. For example, in our project, we obey this kind of simulation, this kind of temperature profile from 0 to 200, and then we heat a little more until 300. So it's a low temperature sintering. After the work of the sintering, the MD sintering, with the centered body, we do some mechanical test. The mechanical test, it means we do some shear test, or we do some strain test, so that we can work out this kind of curves. It's a strain stress curves, and based on this one, we can summarize some mechanical properties to estimate the real properties of such kind of aggregate.
Speak of the tools.
Yeah, the numerical tools it's lumps. It's lumps, which is famous and professional for such kind of simulation, MD simulation. Molecular dynamic simulations. And also, we also focus on the works of the thermal conductivity. As we know, the thermal conductivity for a metal is really difficult to simulate, because the main role which plays the most work for the heat conduction is electrons. But in molecular dynamical simulations, this kind of part is always neglected. So we build our method to measure, to test, and simulate bulk material, which means it's not porous. The result is enough accurate compared to that of the experimental ones. And this first part is the MD simulation for nanoscale, and then after this one, we pass to the second part, the finite element method based simulation for the macro scale simulations. In this scale, we use another program, the surface evolver. This program it's based on finite element method, and the surface of our geometries then consists of a set of triangular finite elements. If we zoom it, we can. I will show you some running program. For example, this one. this is a little program we are studying now. This is an aggregate made by the AutoCAD tools, and then we enter the geometrical informations into this software, and thanks to this we can do some finite elemental based simulations. For example, for this one, the geometrical information was entered inside, and then thanks to this software, the surface divided by thousands of facets. Every facet consists of some edges, 3 edges and 3 vertices. And thanks to some constraint we applied on, we can make some simulations. For example, actually this software is always used for the minimization of the surface energy, and the energy is proportional to the area of the facet. Thanks to this software, we can simulate the centrum process in various mechanisms. For example, the evaporation and the condensation simulations. In this one, we use normally this kind of phenomenon happens in high temperature, but this make me to understand well the theoretical informations about the centering. But for the core of our work is to simulate the surface diffusion and the ground boundary diffusion mechanisms. And for these two mechanisms, we can also use this kind of software, and based on some geometrical geometries, we carried out hundreds of simulations. And the purpose of our final work is to build a centered body, a centered geometry. I'm sorry, I will zoom a little. Because the portrait, yeah, this one. For example, this one is the centered body. This body is one of the part of the joint which connect the optical components with the substratum. Thanks to this geometry, we can estimate its thermal or mechanical properties, because we enter this kind of geometry into some finite element commercial software such as COMSOL. Into COMSOL, we can estimate the kappa, the thermal conductivity, for example, kappa, and also some chemical properties. So this is the plans for my thesis work. Thank you.
Thank you very much.